வாகை சூடவா.
So students, this lesson polymers we divided into two parts. Part 1 introduction, then classification of polymers, and part 2 some important natural and synthetic polymers like bakelite, rubber, and then biodegradable and non-biodegradable polymers. So generally one questions will come from this lesson. So the first part we discussed introduction about polymers and classification of polymers. The next part, that is some important polymers like the natural and synthetic polymers, biodegradable, non-biodegradable polymers, we will see in the next video. Thank you. Dear students, I welcome you all. In this class, we are going to discuss about polymers. You know well, the polymers topic is given in 12th standard. In NEET syllabus, it is a 29th topic. So this topic, we are going to do it in two parts. Part 1, introduction about polymers, classification of polymers, and examples, other things. In part 2, some important polymers preparation like a synthetic polymers, polyesters, bakelite, rubber, biodegradable and non-biodegradable polymers. So most probably you will get one questions from this topic, polymers. Okay. So now let's see this introduction. You know very well polymers. What is the role of polymers in our day-to-day life? Do we use polymers directly? Of course. See, polymers is completely revolutionized our life. See, almost in our day-to-day life, we are very much associated with the polymers. For example, you see plastic, the buckets, cups, saucers, children toys, tires, gears, electrical insulating materials, machinery parts, many things we use in our day-to-day life are polymers. The polymers are backbone of 4 major industries. You know what are the 4 major industries? Plastics, elastomers, fibers, and paint and varnish industries are made up of polymers. So you are going to learn about polymer. What are polymers? Poly means, actually this word is derived from Greek word. Poly means more. Mer means small unit. Many small unit combined to form a big molecule is called polymer. Even the word polymer, the polymers can also be called as macromolecules. So molecules having mass 10 power 3 to 10 power 7 unit. You know what does the U represents? Atomic mass unit, unified atomic mass unit. So the macromolecules having the mass 10 power 3 to 10 power 7 is called polymers. Okay. How the polymers are formed? Many small molecule, you know what is called a small molecule? Monomers combined to form very big long chain molecule is called polymers. The polymers are classified into 4 categories: plastics, resins, that is plastics, elastomers, fibers, and there is plastics is nothing but resin, elastomer is nothing but rubber, fibers are nothing but nylon and terling. You see that? What is a polymer? Polymer is a compound having high molecular weight whose structures are composed of large number of simple repeating unit. You know, when many small molecules repeatedly combine to form a big large molecule. So having a molecular mass 10 power 3 to 10 power 7 is called polymers. Generally, see, the properties of polymers depends upon the molecular configuration and degree of polymerization, branching and cross-linking of this polymer. Okay. See, what is monomer? The small molecule which combine to form a big molecule is called monomer. The small molecule is called monomer. Micromolecules, small molecules readily combine to form a big molecule is called monomer. So students, you remember the word polymer is derived from a Greek word. Poly means many, mer means small unit, small molecule. Many small molecules combine to form a big large single molecule is called polymer. The process, you know what is polymerization? The process of formation of polymer from monomer is called polymerization. Okay. So, let us see this classification of polymers. Polymers are broadly classified into 4 types, 4 classification. 1, based on origin of source, based on source, based on structure, based on molecular force, based on mode of polymerization. Polymers are classified. See, first one, based on origin of source. What is that origin of source? From where we can get the polymer? Based on the origin of source, polymers are classified into natural polymers, synthetic polymers, semi-synthetic polymers. Based on structure of polymers, based on the structure, linear polymers, branched chain polymers, cross-linked polymers are also called as network polymers. Based on molecular force, you can call it as elastomers, fibers, thermoplastic, thermosetting plastic. Based on mode of polymerization, addition polymerization, condensation polymerization. So, students, you remember the examples of each classification is very important. Mostly the NEET examination, they are asking questions based on examples of different kind of polymers, different kinds. So, examples are very important. So, you should remember the example for each and every category. First, let us see classification based on source. What is that classification based on source? See, 3 types: natural polymer, semi-synthetic polymer, synthetic polymer. What are natural polymers? The polymers which are obtained directly from the plant, are found in plant and animals, obtained from the plants and animals, living systems are called natural polymers. Example, proteins, cellulose, starch, etc., rubber, etc. Polymers obtained from natural source, plant and animal, is called natural polymer. Semi-synthetic, remember, see, polymer is prepared using using natural polymer. Polymer is prepared using natural polymer is called semi-synthetic. For example, rayon, cellulose acetate, it is prepared by using natural polymer cellulose, cellulose nitrate. So, these are all called semi-synthetic, that is, the polymer is prepared by using natural polymer, is called semi-synthetic polymers. Synthetic means completely prepared in industries. Only in laboratory and industries it can be prepared. That is called without using any natural polymers. So, that is called synthetic polymers. Example, polyethylene, bunoyous rubber, bunoyan rubber, nylon 66. So, there are variety of synthetic polymers are there. So, remember, classification based on source is 3 types: natural polymer, semi-synthetic polymer, synthetic. So, another classification, this is very important, students, classification based on structure, based on structure. The polymer consists of long straight chains, The polymer consists of long straight chains are called linear polymers. Example, high density polyethylene, and one more, PVC. Remember, polymers containing long chains, straight chains are called straight chain polymers or linear polymers. Example, high density polyethylene, it is shortly called as HDPE. Polyvinyl chloride, shortly called as PVC. Okay, this is linear polymer. Another one, branched chain. What is the branched chain polymers? The linear polymer has some branches but won't link each other. See, look at this, branch chain polymers. The linear polymer chain contains some branching, but the branching will not form a link with the another chain. So, that is type of polymer is called branched chain polymer. Example, low density polyethylene, shortly known as LDPE. So, you remember, based on structure, you can classify as linear polymers, branched chain polymers, then one more, then cross-linked polymers. See, one linear chain, another linear chain, there is a cross-link is formed between the polymers chain is called cross-linked polymer. They are also called as network polymers. So, you remember this is very important. Polymers formed by a molecules, monomers containing bifunctional monomers or trifunctional monomers. Bifunctional, these are usually formed by bifunctional. What is bifunctional? Monomer containing two functional group. Trifunctional, three functional group. Monomers containing two functional group or three functional groups form a polymer, is cross-linked polymer, and there is a strong covalent bond between the chains. Say, remember, example, bakelite, melamine. So look at this. One classification is based on source, natural polymer, semi-synthetic, synthetic. Another classification is based on structure. Based on structure. Based on the structure, we have linear polymer, branched polymer, cross-linked polymer. Okay. And one more classification is based on mode of polymerization. You know very well what is polymerization. Process of polymerization is process in which large molecules, large number of small molecules combine to form a very big single molecule. What is known as macromolecule is called polymer, with or without eliminating small molecule like H2O, water, carbon dioxide, ammonia, like this. So you remember what is polymerization? Polymerization is a process in which large number of small molecules, many number, huge number, maybe 1,000, 10,000, 1 lakh, any number, huge number of small molecules combine to form a large single molecule, what is called polymer or macromolecule, with or without elimination of small molecule like water, ammonia, carbon dioxide, HCl, H2O are called polymerization. Based on the polymerization, polymers are classified into different category. One, you can say that addition polymerization or chain growth polymerization, copolymerization, condensation polymerization or stepwise polymerization. What is addition polymerization? One monomer combined with another, another. No byproducts. So you just keep in your mind, this type of polymerization takes place only in monomer containing double bond or triple bond. That is, unsaturated monomers. Unsaturated monomers will keep on add together, will form a polymer chain, big molecule is called addition polymerization. What about copolymerization? What's the difference between addition and copolymerization? Both, that is, in addition polymerization, the monomer is added with another. But copolymerization, different kind of monomers. If same kind of monomer is there, that is simply called as addition polymerization. Two different monomers add together, that is called copolymerization. And you see, look at the example. Addition polymerization or chain growth polymerization, best example is polyethylene. N molecule of ethylene. What is N molecule? What N stands for? Maybe 100, 1,000, 10,000, 1 lakh, any number, huge number of, very large number of monomers combined to form a large single molecule is called polymer by eliminating small molecule with or without eliminating. Without eliminating, that's called addition polymerization. You see, N molecules of ethylene on polymerization, you will get polyethylene. N molecule of ethylene on polymerization, you will get polyethylene. See, the molecules are add on together, nothing is eliminated. Such type of polymerization is called addition polymerization or chain growth polymerization. Another one, if the monomers are two different monomers, like a Buna-S rubber. Buna-S rubber is made up of 1,3-butadiene and styrene. 1,3-butadiene and styrene. 1,3-butadiene is a one kind of monomer. Styrene is another kind of monomer. When these two are combined to form, when these two monomers are added together, we'll get Buna-S rubber. Buna-S, butadiene, styrene, copolymer. What's the difference between addition polymer and copolymer? See, in both the case, monomers are added together without eliminating, but addition polymerization, only one kind of monomer is involved, say polyethylene. Copolymerization, two different kind of monomers. That's an important thing. Two different kind of monomer. Here also no byproduct, only single product. So that is why it is called copolymerization. N molecule of 1,3-butadiene and N molecule of styrene on polymerization gives BUNA S rubber is an example of copolymerization. One more, condensation polymerization or stepwise polymer, step growth polymerization. What is a condensation? Two monomers of same kind or different kind combine to form a molecule, big molecule, with the elimination of small molecules such as water, carbon dioxide, HCl, ammonia is called condensation polymers. So what is the important condition? The monomer should contain two functional group. Whereas what is the condition for addition polymerization? Monomer is supposed to be an unsaturated molecule. It should contain either double bond or triple bond for addition polymerization. Whereas for condensation polymerization, the monomer should contain at least two functional group of same or different. Monomers containing two same functional group or different functional group combined to form big long polymer is called condensation polymerization. So students, you remember we have classified the polymers based on source, based on structure, based on mode of polymerization, and one more is there based on force of attraction. You see, one kind of polymer cannot be used for all other purpose, for all purpose. See, large number of polymers are there. Say for example, if you make a cut over the rubber tree, you will get a liquid is called latex. That you cannot use it, that coagulate you will get rubber. That you cannot use it to manufacture bucket, mug, toys. So different polymers have different property. The property of the polymer depends upon the tensile strength, elasticity and toughness. These are called mechanical property. The mechanical property of polymers depends upon the intermolecular force, the force. So remember, the application of polymer is mainly depends upon the mechanical property of the molecules, polymers. Mechanical property, what are the mechanical property? Tensile strength, elasticity and toughness. These properties are mainly depends on intermolecular force. What is the intermolecular force? It may be Van der Waals force, hydrogen bond. See, these intermolecular forces will alter the mechanical property. So different proper polymers will have different property, so will have different applications. Remember the polymer, plastics, elastomers, we have a different type. So one type of polymer cannot be used for all purpose, different purpose. They have different properties, so we have different applications. So based on the intermolecular force, polymers are classified into four categories. One, elastomers, fibers, thermoplastic, thermosetting plastics. So you remember what are the four? Based on the, different polymers have different properties. Based on the property, they can be used for different purpose. Okay, we'll see the example for this. So first one, elastomers. Elastomers is a rubber-like solids with the elastic property. These elastomers are chains are held together by weakest intermolecular force. The intermolecular force between the polymer chain is weak and very few cross links, so that once the polymer is on stretching, it gets stretched. When you release the force, it will retract to its original position. So you remember the elastomers are rubber-like solid, and there is a weakest electrostatic, weakest force of attraction, weak binding force between the polymer's chain, so that they can be stretched, and there is a few cross links between the chain, so that they retract to its original position when the force is released. You remember example for elastomer is BUNA N rubber, BUNA S rubber, neoprene. So remember, elastomers are rubber-like solids. They are linear polymers weak attractive force, weak intermolecular force bind the polymer chain. Very few cross links are between the polymer chain, so they retract when the force is released. Example for elastomer is Bunoy's rubber, Bunoyan rubber, neoprene. And one more, another type of polymer, fibers. What's the important thing? Strong attractive force between the polymer chain. The intermolecular force of attraction is very high because the intermolecular force may be like hydrogen bonding or strong intermolecular force. See, the fibers are thread forming solids which possess high tensile strength. They have a high tensile strength, and because of intermolecular force and leading to close packing of chains and impact crystalline nature. So remember, what are the example for fibers? Nylon 66, polyester, it's also called as sterling or dacron. So remember, weak force of attraction between the polymer chain, that is elastomer. Strong force of attraction between the polymer chain, that is called fibers. Example for fiber is nylon 66, polyester is nothing but sterling, dacron. One more, thermoplastics. Remember, thermoplastics are these are linear or slightly branched chain polymer. They become softened on heating, hardened on cooling. What's the important thing? The intermolecular force of attraction is between elastomer and fibers. The intermolecular force of attraction lies between the elastomers and fibers. And remember, they can be softened on heating and hardened on cooling. So heating and remolding is possible for any number of time. If you want, you can mold it. If you don't want the structure, you can heat it and melt it. You can remold it. Heating and remolding is possible for n number of times. Such type of plastics are called thermoplastics. Example, polyethylene, polystyrene, PVC. So you just remember example for thermoplastics, polyethylene, polystyrene, and polyvinyls, PVC. Okay, one more type, thermosetting plastics. What's a thermosetting plastics? It's a heavily branched, heavily cross-linked polymer. Heating and that is remolding is not possible. Once it is molded, it cannot be remolded again. That is called, you cannot recycle it. So such type of polymers are called thermosetting. Heating and remolding is not possible. Example, BAKELITE, urea formaldehyde resin. These are all thermosetting plastics. So students, you remember, we can classify the polymers into 4 categories: elastomers, another one, fibers, thermoplastics, thermosetting plastics, or thermopolymers, thermosetting polymers. So the examples are very important, and let's see some questions based on this first part. Which of the following is a natural polymer? Well, cellulose, bunoyes, rayon, and nylon 66. Here, cellulose is a natural polymer. Bunoyes is a synthetic polymer, completely synthetic polymer. It is prepared from butadiene and styrene. Rayon is a semi-synthetic polymer. It is prepared using cellulose nitrate. So that's why it's a semi-synthetic. Nylon 66 is also synthetic. So the correct answer for this question is cellulose is a natural polymer. Then this is a NEET question, 2018 question. Regarding cross-linked or network polymers, this kind of this question comes from the classification based on structure. Regarding cross-linked or network polymers, which of the following statement is incorrect? So students, you have to be very careful. Read the questions carefully. Incorrect statement. They are asking incorrect. So this question is based on classification based on structure in that cross-linked or network polymer. Examples are, statement A, examples are BAKELITE and melamine. It's a right statement. They are formed from bi or trifunctional monomers. It's also right statement. And they contain covalent bond between various linear polymer chain. Another one, they contain strong covalent bond in their polymer chain. So, the wrong statement is option D. So, remember, they have a covalent bond in the polymer chain, but it is not strong. Only they contain strong covalent bond between the linear chain. Between the linear chain, the interlinking is a strong covalent bond, not this covalent bond in the polymer chain. Then, which of the following is an elastomer? Students, I hope you know that the elastomer is a category, is a type, comes under classification based on force of attraction, based on intermolecular force. Bakelite, you know very well, bakelite comes under thermosetting plastic. Polythene, it comes under thermoplastic. Bunoyes rubber, it comes under elastomer. Polystyrene, it comes under thermoplastic. So, the answer for this question is Bunoyes rubber, it comes under elastomer. Okay. Then next question, which of the following is a linear polymer? Students, you see you are given 4 options: low density polyethylene, high density polyethylene. Low density polyethylene is shortly known as LDPE. High density polyethylene is shortly known as HDPE, melamine amylopectane. And you see, in that the correct option for linear polymer is high density polyethylene, that is HDPE. So, remember, it is a linear polymer. Low density polyethylene will comes under branched polymers. Melamine comes under cross-linked or network polymer. Remember, low density polyethylene comes under branched polymer, high density polyethylene comes under linear polymer, melamine is cross-linked polymer. So, the answer for this question is option B, high density polyethylene. Then, which one is not a condensation polymer? So, important question it is, you know very well. Classification, preparation of polymers. Polymers can be prepared by 2 methods: addition polymerization and condensation. I told you what is the condition for addition polymerization, condensation polymerization. Addition polymers are formed by monomers having double bond or triple bond. That is, unsaturated molecules combine to form polymer is called addition polymers. Whereas condensation polymerization is formed by monomer having bifunctional or trifunctional molecules. Bi or trifunctional molecules condense to form a polymer is condensation, whereas unsaturated monomers combine to form polymer is called addition polymers. Here in this option, dacron or what you can call it as a dacron or terline, this is formed by dacron or terline is formed by glycol and terephthalic acid. So, it has bifunctional compound monomers. Neoprene is formed by chloroprene. So, it has unsaturated monomer. So, only that will form addition polymer, not a condensation polymer. So, the correct option for this question is neoprene. Neoprene is a addition polymer, not a condensation polymer. Today, we are going to discuss about a small topic in chemical bonding. You know well, generally 2 to 3 questions asked from this topic, chemical bonding. Okay. In this topic, there is one subtopic called bond parameter. You know what are the bond parameters given in the textbook? There are 4 bond parameters. One is bond length, bond order, bond angle, bond energy. In this class, we are going to discuss about bond angle. Okay. What is bond angle? The molecules made up of 3 or more atoms, the minimum angle between the bonded orbital, that is between the 2 adjacent bond, is known as bond angle. So, students, you just remember what is bond angle? Molecules made up of 3 atoms or more than 3 atoms. Molecules made up of 3 or more than 3 atoms. The minimum angle between the 2 bonded atoms, that is 2 bonded orbitals or between the 2 adjacent bond, is known as bond angle. It is denoted by the symbol theta. Remember, bond angle is denoted by the symbol theta. Okay. And this bond angle depends upon the atom connected to it. The repulsion between the atoms or groups attached to the central atom may decreases or increases the bond angle. Okay. So, depends upon the bonded atom, the repulsion between the bonded atom may alter the bond angle. It depends on 4 factors. You know what are the 4 factors? 1. Nature of hybridization. You know very well, different type of hybridization, sp3 hybridization, sp2, sp, sp3d2, sp3d3 like this. Then lone pair of electrons on the central atom, then electronegativity of the central atom and electronegativity of the surrounding atom. By using these 4 factors, you can predict which molecule has more bond angle, which has less bond angle, and you can find the correct order of the bond angle. So, generally the questions will be given like this. 4 options will be given: which molecule has highest bond angle, which has the lowest bond angle, or find the correct order of bond angle, or find the decreasing order of bond angle, increasing order of bond angle. These are the possible questions. Okay. If you understand this 4 factors affecting the bond angle, very easily you can answer for these questions. Okay. First one, we see the nature of hybridization. The S character of hybrid bond increases, bond angle also increases. What is S character? What is S character? Percentage of S character. See, if you take sp3 hybridized orbital, in that one s orbital and 3 p orbital involved in hybridization, so the S character is only 25%, whereas sp2 hybridized orbital, 1 s orbital and 2 p orbital is involved in hybridization, so the S character is only 33.33%. Whereas if you take sp hybridized orbital, 1 s orbital and 1 p orbital is involved, so the S character is 50%. So, students, you remember the bond angle is directly proportional to S character of the hybridization involved in the bond. More S character, more bond angle. More S character, more bond angle. So, you remember molecules formed by sp hybridization has more bond angle than sp2 hybridized and sp3 hybridized. Okay. Look at the example given. Beryllium chloride, it is a molecule made up of sp hybridization. BeCl3 is a molecule made up of sp2 hybridization. CCl4 is a molecule made up of sp3 hybridization. So, we know this hybridization in this sp hybridization, sp2 and sp3. So, S character decreases, so bond angle is also decreases. See, beryllium chloride has highest bond angle because sp hybridization, S character is 50%. CCl4 has sp3 hybridization, S character is only 25%, that is why lesser bond angle. So, S character increases, bond angle also increases. Look at the order. BeCl2 has more bond angle than BeCl3 and BCl3, boron trichloride, and which has more bond angle than CCl4. The next one, number of lone pair of electron. Suppose if the molecules, the given molecules are all the molecule has same hybridization, how to predict? Same hybridization. Molecules are same hybridization, then the bond angle depends on number of lone pair of electron. Number of lone pair of electron increases, bond angle decreases approximately 2.5%. So, look at the example, methane, ammonia and water. All these 3 molecules as sp3 hybridized, same hybridization, but you see they differ in lone pair of electrons. Methane has 0 lone pair, ammonia has 1 lone pair, water has 2 lone pair. So, number of lone pair of electron increases, bond angle decreases. So, methane has 109.5 degree, ammonia has 107 degree and water has bond angle 105. This is because the lone pair of electron increases, bond angle decreases. Another factor, electronegativity of the central atom. You see, you should consider the electronegativity of central atom and electronegativity of bonded atom. The electronegativity of central atom increases or decreases, bond angle also decreases. See, bond angle is directly proportional to electronegativity of the central atom. Look at the example: water, H2S, H2O, H2S, H2SE, selenium hydride, tellurium hydride. The electronegativity of the central atom, oxygen, sulfur, selenium, tellurium decreases, so the bond angle is also decreases. Okay. Another important topic, another that is factor, electronegativity of surrounding atom. Look at this surrounding atom. The electronegativity of surrounding atom decreases, bond angle increases. So don't get confused. Electronegativity of central atom decreases, bond angle decreases. Electronegativity of surrounding atom decreases, bond angle increases. And look at the example: PCl3, PBr3, Pi3. In all these cases, central atom is phosphorus, but the surrounding atom is chlorine, bromine, iodine. The electronegativity of chlorine, bromine, iodine decreases, so the bond angle increases. One more example is also given: arsenious trichloride, arsenious tribromide, and arsenious triiodide. What happened? The electronegativity of chlorine, bromine, iodine decreases again, so the bond angle increases. So students, you remember the four factors. What are the four factors? Nature of hybridization, number of lone pair of electrons, electronegativity of the central atom, electronegativity of the surrounding atoms, that is bonded atom. If you consider these four factors, you can definitely give a correct answer for the questions based on the bond angle. Based on these four factors, you can give exact answer for the questions based on the bond angle. Let us see some examples based on this bond angle. Some questions based on bond angle. Say question number 1, which of the following is the correct order of bond angle? You are given 4 molecules: acetylene, that is ethane, methane, ammonia, and water. First, you see acetylene has a bond angle of acetylene is a sp hybridized, whereas methane, ammonia, and water are sp3 hybridized. So remember, sp hybridized has more s character. So acetylene has highest bond angle, whereas all the other 3, methane, ammonia, and water, all the 3 are sp3 hybridized, same hybridization. Then what is another factor you should look into this? Number of lone pair of electrons. So methane has no lone pair, ammonia has 1 lone pair, water has 2 lone pairs. So water has lowest bond angle. So what's the correct order of bond angle? Acetylene has highest bond angle, then methane, then ammonia, then water. So 2 factors we are used. One, nature of hybridization, and then lone pair of electron. By using the 2 factor, we have explained, we have find the answer, that is option B. Then question number 2, correct sequence of decrease in bond angle of the following hydrides. You know, what is the concept, what is the factor we should use? The electronegativity of central atom. You see, only the central atom is different. Electronegativity of central atom decreases, bond angle also decreases. So therefore, the correct answer for this question is A, because electronegativity of nitrogen is more than phosphorus, more than arsenic, then more than antimony. The electronegativity decreases in the order nitrogen, phosphorus, arsenic, antimony. So bond angle also decreases. So correct option is A. Now question number 3, true order of bond angle. That is, which order is correct? Again, if you look at these options, only the central atom is different. Central atom is different. Surrounding atom is same. Central atom is different. So what is the rule or what is the factor? Electronegativity of the central atom decreases, bond angle also decreases. So the answer is A, because oxygen is more electronegative than sulfur, sulfur is more electronegative than selenium, selenium has more electronegative than tellurium. So electronegativity decreases, bond angle also decreases. So the option A. Next question. The largest bond angle. Which has the largest bond angle in this case? If you Look at this, ASH3, NH3, H2O and PH3. All these molecules has same hybridization. What is that hybridization? sp3. Then in which case you can find out? See, arsenic hydrides, ammonia and phosphine, option A, B, D has only one lone pair of electron, whereas water has two lone pair. So all are having same hybridization, but they differ. Option C is differ in lone pair of electron. So water has lowest bond angle. So we can neglect. Then among the rest of the three, arsenic hydride, ammonia and phosphine, nitrogen is more electronegative than phosphorus. Phosphorus is more electronegative than arsenic. So which is based on electronegativity we can choose. So electronegativity of the central atom we can choose. So therefore the correct option is ammonia. So students, you are applying two concepts here. One, lone pair of electron. Water has two lone pairs, so it has lowest bond angle. So you can discard. Whereas other three options, nitrogen is more electronegative than phosphorus and arsenic. So more electronegative, more bond angle. So that is ammonia has more bond angle. So easily you can predict the 4 points. One, nature of hybridization, lone pair of electron, electronegativity of the central atom and electronegativity of the bonded atoms is enough to understand the concept and answer this for any questions in the NEET exam. One more question. Which of the following has the maximum bond angle? Students, you see the 4 options. All the 3 central atoms are same. Boron, boron trichloride, boron tribromide, boron trifluoride, and all the 3 central atoms are same. Then how can you find out? See, when the electronegativity of the bonded atom, surrounding atom decreases, bond angle is increases. So we know which is more electronegative. Fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine. So electronegativity decreases, bond angle is decreases. So the correct option is B. Boron tribromide is a more bond angle or maximum bond angle.
இந்நிகழ்ச்சியை பற்றிய தங்களின் மேலான கருத்துக்களை கீழ்க்கண்ட முகவரிக்கு கடிதம் மூலமாகவோ மின்னஞ்சல் மூலமாகவோ குறுஞ்செய்தி மூலமாகவோ தெரியப்படுத்தலாம். அனுப்ப வேண்டிய முகவரி சிறப்பு அலுவலர், கல்வி தொலைக்காட்சி, 8ஆம் தளம், அண்ணா நூற்றாண்டு நூலகம், காந்தி மண்டப சாலை, கோட்டூர்புரம், சென்னை 6085. தொலைபேசி எண் 7824015000.